Hello there. A hearty welcome to Moody Institute of Science. For several years here at the laboratory, we've been studying the human senses. And the deeper we go into the subject, the more fascinating and wonderful it becomes. As we explore the mysteries of sense perception together, we're going to have a lot of fun. There'll be some surprises and quite a few chuckles. But also, we're going to discover that there is real significance in the study. How many senses are there? Well, more than the traditional 5. A lot more. But it's not without reason that these 5 have been called the windows of the soul. The sense of sight, which opens to us all the beauty and wonder of the world around us. The sense of hearing and the many voices of the world. The sense of taste with its endless delights. Oh yes, and that wonderful sense of smell. The sense of touch with hands both young and old. Viewing the senses individually, we find that they are wonderful indeed. But our senses don't function independently. They operate together as a team, forming a smoothly integrated, complex electronic system. Let's watch this system work at a baseball game. Nice catch. But let's take a closer look at the electronic magic behind that catch. At the instant the ball was hit, countless bits of information were flashed to the outfielder's brain. His eyes told him the angle at which the bat hit the ball and the direction it was starting to travel. His ears told him how squarely and how hard the ball was hit. His sense of touch gave him clues as to wind direction and velocity. And from his memory came thousands of clues gained through past experience. This information was combined to solve a complex problem involving geometry, trigonometry, calculus, and ballistics. And he makes the catch. In a single day of normal activity, it is probable that the sensory system of your body will handle more messages than have been carried by all the telephone and telegraph lines in the whole world during the past 50 years. The human senses are wonderful, and they serve their intended purposes well, but in their ability to perceive the world around us, they are extremely limited. Let's take the sense of sight, for example. Now, our eyes are sensitive to a particular range of frequencies, which we call visible light. But visible light is merely a small part of the electromagnetic spectrum, which includes electric waves, radio waves, infrared, ultraviolet, X-rays, gamma, and cosmic rays. Now, in a very real sense, all of this is light, but nearly all of it is light we cannot see. These frequencies have special meaning for us merely because they are the ones to which our eyes will respond. Now, of course, electric waves and radio waves have different properties because they're different wavelengths. But that same thing is true of any part of the spectrum. Even in the visible spectrum, there are different wavelengths which have different properties. In the electromagnetic spectrum, the longest waves are the electric waves, which commonly supply us with power. Electric waves are some 3,000 miles in length. But as they become shorter and vibrate faster, they gradually merge into radio waves. The longer radio waves we pick up on our standard broadcast receivers. For shorter waves, we have to use shortwave receivers. television sets, various radar systems. But as the waves become shorter and vibrate still faster, we move into the infrared section. These waves cannot be tuned in on our radio or TV sets. Instead, we tune them in on our bodies and call them heat. Wavelengths of invisible infrared light are so close to the longest waves of visible light that often both can be detected at the same time. Moving across the visible spectrum, the waves become shorter and vibrate faster until finally visible violet disappears into invisible ultraviolet, sometimes called black light. Now, ultraviolet rays are too short and vibrate too fast for the human eye to see, but there are ways we can see their effects. Sunburn, for instance, is caused by invisible ultraviolet light. Some minerals can change invisible ultraviolet light into frequencies we can see. Rather ordinary looking, aren't they? Well, now let's shine some invisible ultraviolet light on them. Instantly, they flame into glowing beauty as short waves of invisible ultraviolet light are sent back as longer waves, which we can see. Traveling farther down the spectrum, we come to X-rays. Now, of course, our eyes are not sensitive to X-ray light, but photographic film is, a fact made use of every day in medical laboratories. So in reality, we who think we see so much are groping around in a world ablaze with glory and wonder and light and color, and we're almost totally blind. Now, does this mean that our sense of sight is any less amazing and wonderful than we had supposed? Not at all. It merely means that the universe around us is infinitely more wonderful than anything of which we've ever dreamed. Now, all of us have heard someone say, "I will not believe in anything that I cannot see with my own two eyes." Well, the very least that you can say about such a person is that he must have a narrow view of the world around him. Yes, our vision certainly is limited. But how about the sense of hearing? Is it also limited? Well, did you ever hear one of these? Quiet, isn't it? No, not really. This is an ultrasonic dog whistle. Actually, the sound is very loud. A dog can hear it all over the neighborhood. But it's beyond the range of the human ear. Now, we've built a super high-powered dog whistle. In the science laboratory, it's called a Galton whistle, after Sir Francis Galton, who invented it. The whistle is now blowing full blast. Though completely inaudible to us, it is of tremendous intensity. In fact, it is so loud that the sound can actually be used to support objects in midair. The silent sound from the whistle is bounced back and forth to form a standing wave pattern. These waves whip the air molecules into a stormy sea of violent motion, except at 2 points in each wave. It's at these points, or nodes, that the cork chips are suspended. This world of silent sound brings man face to face with a realm far beyond the narrow limits of the human senses. Now, before the molecular nature of matter was known, the sense of smell and, to a lesser degree, that of taste were almost a complete mystery. Knowledge, however, has not lessened the wonder of these so-called chemical senses. It has merely enabled us in some small degree to appreciate their wonder. Now, any substance is composed of invisible particles called molecules. These particles are in continuous movement. In some substances, the movement is so violent that particles near the surface go shooting off into the air. This is what gives a substance an odor. Dramatic proof of this may be had by pouring some mercury into a dish. And then carefully sprinkling the surface of the mercury with a fine powder. Now, if we bring a substance with a strong odor close to the surface of the towel, The powder will be pushed violently away by the invisible particles coming from the substance. A man has devised instruments so sensitive that they can detect one part of a substance in 10 million parts of air. Your olfactory organs, however, can detect one part in 1,000 million. But compared to that of many animals, man's sense of smell is quite limited. The bloodhound, for instance, has the extraordinary ability to follow a scent when it's hours or even days old. But perhaps the most limited sense of all is the sense of taste. Yes, even the man who prides himself on a very discriminating sense of taste is limited, like the rest of us, to just 4 kinds of taste buds: salt, sweet, sour, and bitter. Did you know that if a person is blindfolded, with his nasal passages completely blocked, he can't tell the difference between an onion, an apple, a pear, or a potato? It's a fact. It's only the odor that makes the flavor different. As we began our study of the mysteries of sense perception, one of the first things we had to recognize is the fact that we do not see with our eyes or hear with our ears. These are merely the external receptors. The real seat of sense perception is in the brain. It is here that we see and hear and detect odors and taste our food and otherwise sense the world around us. And it's a good thing that this is so. For example, if seeing were done only in the eye, everything would be upside down to us. Just as in a camera, the lens of the eye forms the image upside down. The image is then inverted by the brain so that it appears right side up. Now, what would happen if a lens system were used to form the image right side up? Well, the brain would immediately invert the image so that it would be upside down. But would this condition be permanent? To answer this question, we asked Mr. Gratz, our optical expert, to design for us a pair of inverting spectacles. While the spectacles were being constructed in our shop, we faced the problem of who was going to wear the things continuously for several weeks. You'll want to meet our unlucky winner. That's right, me. Even from the first, it was possible to walk in this topsy-turvy fashion, but it didn't take long to develop a rollicking case of seasickness. We decided that for your sake as well as ours, we'd better conduct our first test sitting down. However, just sitting down wasn't so easy. Even the simplest tasks were at first impossible. No amount of concentration or effort could overcome the compulsion to reach in the wrong direction. The inverting spectacles had to be worn every waking moment during the entire period of the experiment. Anytime the glasses were removed, the eyes were closed or fully covered. Walking to work upside down was an exhausting experience, but it provided a valuable period of relearning and reorientation. It also caused quite a stir in the neighborhood. Gradually, it became easier to get around in this upside-down world. By a slow and painful process, the image in the brain had been erected. At this point, we decided to devise a convincing demonstration showing that reorientation had been achieved. The tests with the motorcycle went so well that we decided to extend the experiment to flying an airplane, where visual coordination and depth perception are even more critical. The flight lasted more than an hour, during which all normal flight maneuvers were executed. In performing the experiment with the inverting spectacles, we became very much aware of how important it is that seeing is done in the brain, not just in the eye. When you look at a brick wall, for example, staring straight ahead with one eye closed, there is a hole in the picture image sent to your brain. The hole is irregular in shape and occurs 12 degrees to one side. However, try as you will, you won't be able to see the hole. Your mind will fill in the missing detail brick by brick. But why is the blind spot there in the first place? The answer lies in the amazing construction of the eye. The inner curved surface at the rear of the eye, called the retina, is a fantastic thing. Its function is to transform a visual image into electrical impulses which are collected by a network of more than 1 million tiny nerve lines which carry the visual image to the brain. The blind spot occurs at that point in the retina where the nerve lines join the optic nerve. At this point, there are no seeing elements. Now, it's a good thing that this spot is not in the center of the retina, for if it were, our vision would have been seriously impaired. As it is, however, the hole is always there in the image sent to the brain, but the brain always fills in the hole with detail similar to that which surrounds it. But someone says, well, maybe I don't see everything around me. But if what I do see, I see correctly, I'll still trust my senses. Well, recently there's been a great deal of careful research and study into the subject of the accuracy of the senses, and the results have been quite amazing. The scientist, Adelbert Ames, has developed some ingenious experiments. In this figure, the two ends obviously are parallel, but the two sides are not parallel because the two ends are not the same length. This figure we call a trapezoid. Now let's remove the cover. Are you a bit confused? Well, all we've done is cut some holes in the figure and painted it to look like a window frame. But maybe you say, well, you can't fool me, that's still a trapezoid. Well, it's still a trapezoid, all right. But now let's revolve the figure and see what happens. Does the window frame seem to turn, then stop, and reverse directions? Well, such is not the case. It is revolving continuously in a clockwise direction. Now, even when we know this, the illusion still persists, and it looks more like a window all the time. Well, maybe you need a reference point. See if the cube will help you follow the edge of the trapezoid all the way around. Watch closely now. Doesn't help a bit, does it? Not only does the trapezoid still oscillate back and forth, but the cube actually seems to take off and go floating through space. Now, it doesn't, of course. Actually, the cube has been firmly attached to the edge of the figure all the time. Now, an iron bar should make a good solid reference point. Let's see what happens now when we rotate the window. Of course, we know that the revolving window frame cannot possibly bend the iron bar or cause it to cut through the window frame. But this knowledge seems to be of no help at all. The illusion of an oscillating window still continues. From earliest childhood, it has been our experience that windows are rectangles and that all sides are parallel. Your eye sent an accurate image to the brain, the image of a trapezoid painted like a window. But your mind said, ah, that's a window. And rather than give up the idea that all windows are rectangular, your mind accepted all sorts of improbable things. Solid bars bending or cutting through solid matter without even leaving a hole. We emphasize the fact that seeing is done in the mind, not just the eye. And I think you're beginning to see the importance of this emphasis. But Adelbert Ames had some other experiments which were most revealing. Now, as I step into this room, it should be quite obvious that something is wrong, but can you figure out what it is? Your mind may tell you that I have grown smaller. Of course, you know that that really isn't true. Your eyes, however, are telling you the truth. They're telling you that the floor is tilted up, that the ceiling is tilted down, that the walls are badly distorted, that the windows would be almost impossible to make drapes for them. Yes, your eye is telling you all this, but your mind simply refuses to believe it. But maybe this will help. Imagine all of this without benefit of vitamins. But it also works the other way, too. Now, if you'll just step back a bit, you'll see the real cause of the trouble. It's quite obvious at this distance, isn't it? Sloping floor, tilted ceiling, distorted walls. But since you understand this, you shouldn't have a bit of trouble from now on, should you? Or should you? In this house, faces at the window seem to come in assorted sizes, don't they? But there's nothing wrong with the faces. It's those windows and what they're doing to your brain, remember? A small one and a tall one. Let's see if we can even things out a bit. Oh, no, that's even worse. It comes as a distinct shock to most people when they realize how limited and how inaccurate the human senses really are. Now, of course, the scientist is keenly aware of these limitations. In fact, this awareness is the very foundation of modern science. Before the age of science, man had no real concept of an orderly universe governed by unchanging law. He proudly built his theories and philosophies on the meager scraps of information coming from his limited and inaccurate senses. This was a time when alchemists mixed their magic potions, when astrologers tried to predict the future, when phrenologists measured bumps on the head to gauge a man's intelligence. But about 300 years ago, the picture began to change. The age of science was born when man quit trusting his senses and developed instruments to overcome their limitations. Today, man knows that the physical world is governed by universal and unchanging law that has been operating since time began. Man knows that there is rich reward for strict, detailed obedience to physical law, and also a stern penalty for disobedience. He knows that sincerity and good intentions are not enough. Now, this attitude in the scientific realm is relatively new, but it certainly has paid off. As soon as man adopted this attitude, there was a sharp upturn, literally an explosion in scientific progress. And yet, with all the potential for good, this scientific development has brought man face to face with the greatest crisis in human history. Why do we face this crisis today? Well, man has developed an enormous scientific competence almost overnight. But in the spiritual realm, man has all the symptoms of a pre-scientific Dark Age philosophy. He seems to feel that this is a realm composed entirely of intangibles, a realm in which there are no absolute values and no fixed laws. Because man recognizes no law outside himself, he feels free to set his own standards and develop his own set of laws. In other words, once again, man is committed to trusting himself. He feels free to build his own theories and philosophies purely on the meager scraps of information coming from his senses, which in this realm are even more limited and unreliable. How often today we hear someone say, "Well, I have my own religious philosophy." Can you imagine a chemist saying, "I have my own table of atomic weights"? He'd blow his head off in 10 minutes. Such an attitude applied to the physical realm is obviously ridiculous. But is it any less ridiculous when applied to a realm that is far more critically important? Now, if in the physical realm there are absolute values and fixed laws, is it not logical to assume that there is also a master plan in the moral and spiritual realm? And if we dedicate ourselves to obedience to that plan, can we not expect a similar explosive result? But now, the important question. Where can we find these absolute and unchanging moral and spiritual laws? Well, we can find a partial answer in nature. For after all, spiritual laws have a counterpart or parallel in physical law. The law of cause and effect, for example, operates in both realms. History is also a source of information, for the history of mankind is but a record of the inexorable operation of these laws. In the history of nations and in the lives of individuals, we see the result of obedience to God's laws, and also the tragic consequences of disobedience. And then we have this book, the Bible, the Word of God to man. Wherever it has been loved and believed, it has transformed lives and even altered the course of history. But how can we know that this is the law of God? Well, this is a beautiful opportunity to put the scientific method to work. Put these laws to the rigorous test of personal experience in your own life. And what result shall we expect? An explosive change. A change so complete that the words salvation, conversion, and born again will take on a wonderful new and personal meaning.
In an immense universe, stretching through the vastness of space, is our nearest neighbor, the moon. Man has actually walked on its dry, dusty face. We now know with certainty that it is barren, desolate, devoid of even the simplest forms of life. The planet Earth, our home, a sphere of striking beauty. What a colorful contrast, green, fresh, fertile, and teeming with life in great profusion. a dazzling diversity of life. What makes the difference between the lifeless moon and the living Earth? There's nothing else quite like water in the entire universe. In a surprising variety of ways, the peculiar properties of water seem to have been designed expressly to make the world hospitable to life. And the Earth has a great abundance of water. It covers about 70% of the Earth's surface. That's an estimated 326 million cubic miles of water. If the surface of the Earth were perfectly smooth, the waters of the oceans would cover the Earth uniformly to a depth of between 8,000 and 9,000 feet. However, only a fraction of 1% of all the water of Earth can be called fresh water, or water suitable for our personal use. Most of us tend to regard this remarkable substance as ordinary, but we must not take it for granted. For in reality, it is the most extraordinary substance in the universe, and one upon which we are totally dependent for life. Just a glass of ordinary water, how much would you say it is worth? Actually, it's priceless. It takes 300 gallons of water to produce one loaf of bread, 700 gallons to refine a single barrel of petroleum, 4,000 gallons to provide 1 pound of beef, 10,000 gallons to build one automobile. Perhaps it's time we allowed ourselves to appreciate what water really is. Almost everyone knows the symbol for water, H2O, 2 atoms of hydrogen and 1 atom of oxygen. Rather short as chemical formulas go, but that's water. Now, hydrogen itself is a gas and very common. It also happens to be the lightest of all elements and was used to inflate the Hindenburg and other lighter-than-air craft. But hydrogen is not only very common and very light, it is also very flammable. Oxygen also is a part of water, and it too is a gas. Oxygen readily supports combustion. In the presence of pure oxygen, even steel will burn. And so will the inside of a space capsule, and with what tragic results. Now think of it. 2 gases, hydrogen, which is highly combustible, and oxygen, which supports combustion. When combined in precisely the right proportion, form water, man's chief agent for putting out fires. Here's another thing about water on which we depend daily, perhaps without realizing just how unusual it is or why it happens. When you heat water to 212 degrees Fahrenheit, it ceases to be a liquid and becomes a gas. When you cool water to 32 degrees Fahrenheit, it freezes. Why water reacts precisely as it does can be understood only by examining the structure of the water molecule itself. Do you have any idea how small a molecule of water is? In just 1 ounce of water, there are 1 trillion molecules. A water molecule is only 1/18 billionth of an inch in diameter. Human eyes have never seen anything that small. But we do know something about how the molecule behaves, and why it seems to be different from the molecules of other substances. The molecule itself looks something like the head of a mouse. The parts that look like the ears of the mouse represent two hydrogen atoms. The larger part represents an oxygen atom. Hydrogen and oxygen, two elements quick to join each other and once together, difficult to separate. The reason? There's a strong electrical attraction between them. The hydrogen atoms in the molecule are at an angle of 105 degrees to each other. As a result of this, there is an unequal distribution of electrical charges within the water molecule. The hydrogen atoms become positively charged, the oxygen atom negatively charged, and the molecule itself becomes dipolar. It has two poles like a magnet. Because of the shape the molecule forms, scientists sometimes refer to it as the lopsided molecule. This configuration accounts for many of its unusual and unique properties. When this much sugar is poured into this much water, it would seem reasonable to assume that the water would overflow. But actually, because water is a most remarkable solvent, the sugar disappears without significantly affecting the level of the water. Given enough time, water will dissolve almost any other substance, for it comes closer than any other liquid to being a universal solvent. It is this ability to dissolve that plays an important part in erosion. As water erodes, it picks up chemicals and minerals. Were it not for the ability of water to dissolve or break down the molecular structure of other substances, plants would not get the nutrients they need. Water's force in motion is another factor dramatically evident in its power to erode. Its relentless motion through continuing centuries has helped to shape Earth's surface in rugged artistry. Cutting and chiseling through solid rock, water has sculptured deep, twisted canyons of spectacular grandeur. Have you ever wondered why water forms into a drop, a bead? How it holds itself together? Again, the explanation is found in the molecule. Once formed, water molecules join to each other in a sort of liquid latticework. The negative side of one molecule is attracted or joined to the positive side of another. In the liquid state, these attractions, or bonds, are formed and broken at random. At the surface where the liquid stops, the surface molecules cling to the ones below and to the sides. This cohesion is what is called surface tension. It creates a kind of skin that holds the water together. A drop of water takes the shape of a sphere. The skin holds the sphere together. A water strider walks on water. The skin provides a surface. A steel plate actually floats on water. The skin holds it up. Water skin is also illustrated in the old saying, like water off a duck's back. It is surface tension which causes water to bead and roll off the bird's back. Actually, due to surface tension, these coots are sealed in an envelope of air as they dive. But perhaps the greatest work of water's surface tension in supporting life is cohesion, or capillarity. Capillarity is the force that causes water to rise in a constricted space. The greater the constriction, the greater the rise. To further illustrate this principle, the stem of a white carnation is split and placed in containers of colored water. Through time-lapse photography, we see what happens. As water goes up the trunks of trees, capillary action is again at work. Without the ability of water to creep upward against the pull of gravity, the chemicals and minerals needed by plants to manufacture food would remain in the ground. Cohesion or capillarity is a phenomenon of water necessary to sustain life on Earth. In its solid state, water exhibits another phenomenon essential to life. In the days when the milkman delivered his product in a glass bottle, what happened when the milk was left outside and the temperature was below freezing? Again, the time-lapse camera speeds up the process. But actually, this is what takes place only over a longer period. Milk is 87% water. It is the water in the milk that is frozen and expanded. Almost any other substance, like this melted paraffin, whether solid, liquid, or gas, will shrink in volume as its temperature goes down. As it shrinks, it becomes more dense. Water also shrinks during most of the temperature drop toward the freezing point. But below 40 degrees, something amazingly different happens. It expands and gets less dense. As it freezes into a solid, it becomes still less dense until it has finally gained about 9% in volume. This cast iron container filled with plain water, H2O, is placed in a beaker containing liquid nitrogen to cause the water inside to freeze quickly. As water expands and freezes, it releases tremendous energy. Fast, wasn't it? Let's see it again in slow motion. As you can observe, enormous energy was involved as the water froze and expanded. So why does ice float? Because ice occupies more space than liquid water without weighing anymore. Since ice floats on the surface, it acts as a layer of insulation which protects the water beneath from further freezing. Now, if water, like other liquids, were to become more dense when frozen, ice would sink, and more ice would be formed at the surface. In the wintertime, the rivers and streams would freeze and stop flowing. Lakes would freeze solid. And even the oceans might eventually become a solid mass of ice. In the summer, the sun's heat would melt only a thin layer on the surface, forming a shallow slush. Life would have little chance for survival. But God created the earth so that it might sustain life. Therefore, the molecule of water had to be different from the molecule of all other substances. With the warmer temperatures of spring, ice readily melts. The melting liquid flows from higher elevations to lower elevations, forming bodies of water. There, water vapor is lifted up by the heat of the sun, and the water, the sun, the air, and the force of gravity work together, as they have for centuries, to keep the hydrologic or water cycle going. Warm, wet air is lighter than cold, dry air, which causes it to rise. These clouds began as rising currents of warm air laden with moisture. Borne by prevailing winds, the moist air cools as it rises higher and higher up steep mountain slopes and contracts as it cools, literally squeezing out most of the moisture as refreshing rain. Raindrops wash the air, absorbing carbon dioxide as they fall, returning it to the soil as carbonic acid, vital to plants, and providing pure, fresh water for animal and human life. 3,000 years before the principles involved were discovered by modern science, the Bible described the water cycle with amazing accuracy. All the rivers run into the sea, yet the sea is not full. Unto the place from whence they come, thither they return again. More energy is expended in the water cycle in one day than man has been able to generate throughout the course of history. This alone should make us stand in awe at the power of our God. God's power can also be seen in the conversion of salt water to fresh. Man has long sought for a simple, inexpensive way to remove salt from seawater. Survival kits such as this one employ solar stills. They operate through a process of evaporation and condensation, a process that God has been utilizing for thousands of years. The process is referred to as desalination or desalting. These solar stills do successfully make the conversion, providing fresh drinking water from the undrinkable ocean. Huge plants have been developed for converting larger amounts, but so far the cost of converting enough for even one city is comparatively expensive. However, desalination could well become our prime source of fresh water. Yet from the very beginning, God has converted billions of tons of salt water to fresh every day. We've considered many different things about water and its unique properties. All the evidence indicates that water possesses precise properties that make life possible. These properties were not acquired through a process of random change, but were designed into water from the very beginning by the master designer, by God Himself. What does all this mean to you personally? Think again of how much we use water. Every day we use it in hundreds of ways. In a very personal way, water means a great deal. Really, it's a matter of life and death. 70% of the average human body is water. You are constantly losing this precious body liquid, and if it's not replaced, and fairly soon, you will die. It's the water in your blood that carries it through 60,000 miles of arteries, veins, and branching capillaries. Water plays a major role in the digestion of your food. It serves to lubricate your joints. Your mucous membranes would dry up without it. Without water, your eyes would cease to function. Water regulates your body heat. Right at this moment, as from the beginning of time, water is supporting life on Earth, your life. Water, with its precise properties, is God's loving provision for our physical lives. As we have seen, its formula is simple, but it is also very special, very exact. Man did not create water and cannot change the formula, but he is absolutely dependent on it. Water has no man-made substitute. Where the waters run, there is life. Where they do not, there is desolation and death. But this book, the Bible, the Word of God, speaks of another kind of life, spiritual life, and reveals another kind of water, living water. The living water, or spiritual water, is the Lord Jesus Christ. To a lonely, misunderstood, and sinful woman long ago, Christ said, "If you knew the gift of God, and who it is who says to you, 'Give me a drink,' you would have asked him, and he would have given you living water." However, just as God's provision for man's physical life is precise, so his provision for man's spiritual life is precise. Just as man did not create physical water, so he cannot create spiritual water. Just as he cannot change the formula for the one, so he cannot change the formula for the other. Just as man will die physically without the one, so he will die spiritually without the other. But just as physical water is abundantly available to man, so the spiritual or living water is also. And the formula is simple. But the formula is also special, exact, and precise. Jesus said, "No one comes to the Father but through me." Man is confronted with an awesome alternative. He can receive the spiritual water and live, or he can reject it and die. But remember, just as physical water can be yours for the taking, yours for the drinking, so the spiritual water also can be yours for the asking, yours for the receiving, free, without cost. Christ's invitation given centuries ago still stands. "If any man is thirsty, let him come to me and drink, and from his innermost being shall flow rivers of living water." My friend, receive Christ now, and you can experience eternal life, and your spiritual thirst will be fully and finally satisfied.